Hi girls, this video I give you an introduction to electrochemistry, which is achievement standard 91393. This standard is called Demonstrate an Understanding of Oxidation Reduction Processes, and it's worth 3 credits. Now, if you remember, this oxidation reduction is a topic that you were taught last year in level 2. So you were given the fundamentals of it last year, and this year you are expected to demonstrate an understanding, so being able to apply the concept of oxidation reduction in different processes. It is worth 3 credits and it's internally assessed. So what are you expected to know in this topic? There's a few of these points here. You can have a look at them later. But what I would like to highlight is that these bullet points that I've just drawn a line, these ones are all coming off your level 2. So if you struggled with oxidation reduction last year, you had some doubts or didn't really get part of it, now is a good time to go back and do some revision, because half of the assessment is drawing on things you were taught last year. Now this bit here, that's something new that we're going to teach you, and it will only make sense if you've got all of this sorted out already. So over the next few videos, I'll take you through all that is required for you to be able to get through this assessment well. What you need to do is use the video, use the resources given by your teacher, and get a book or whiteboard or something, write and learn, right? So remember my first video, my first slide said this topic is called electrochemistry. If you're wondering what electrochemistry is, I thought I'll just give you an introduction. Now, electrochemistry is it's a concept that is used to explain chemical reactions, certain types of chemical reactions. And if you remember in level 1, when you were in year 11, you were taught about chemical reactions, and you were taught 4 different chemical reactions. If you remember, that's displacement, precipitation, combination, decomposition. And this year, and then that was level 1, then level 2, we taught you about redox, which is oxidation reduction happening simultaneously in a chemical reaction. So the answer to the question, what is electrochemistry, is it's a chemical reaction in which electrons pass from one chemical substance to another, and we know that those sort of chemical reactions are called redox reactions, when there's a transfer of electrons. Electrochemistry is the chemistry of those reactions that involve the transfer of electrons from one chemical species to another. So really, electrochemistry is a chemistry of the redox reaction. What happens? I've got a little picture and I've got an example to explain it to you. What happens in a redox reaction? So we've got an example of a strip of copper is being placed in a solution of silver nitrate. Now, I don't know if you remember, but copper is a pink solid. Alright, and so that's the wire that you see there. Whereas silver nitrate is a solution, it's a clear, colorless solution. Alright, so you have a pink metal that's being placed in a clear colorless solution. Then what is this blue stuff that you're seeing here, and what's all this ugly glucky stuff that's growing on top of this pink metal? Can you explain that? Alright, so this is again something you've done last year, it's not something new. So if you try to go back to level 2 topic, what happened to the copper is that the copper was oxidized, and it's oxidized because it lost electrons. Do you remember this? Loss of electrons is oxidation. So it was oxidized, and it goes from being carrying no charge in elemental copper to forming copper 2+ ions. And then maybe now you recognize the copper 2+ ions are the ones that give you that blue color. Okay, so half equation there is copper, solid copper, to then losing 2 electrons to form copper 2+ ions, which is a blue color, Now the other chemical that's involved in this reaction is we have silver nitrate, of which nitrate is actually the spectator. So you're now left with silver ions. Alright, so silver is in that solution from silver ions, not solid silver. So what happens next is that the silver ions, they get reduced because it gains the electrons that were lost by copper. And reduction, remember what it was. What is reduction? Gain of electrons is reduction. So silver ions, they gain electrons, they are reduced, and now it forms elemental silver. Where do you think that elemental silver is forming? Here. This is the pure silver that's being formed on the outside of the copper strip. Over time, maybe this picture doesn't pick it up so well, but you can actually see the beautiful silver crystals forming on top of that wire. So there is a simple redox reaction. Copper oxidized, silver ions reduced. And all this was possible because there was a transfer of electrons. The electrons that were lost by copper were gained by silver. Simple redox reaction. Now there's a half equation there. So silver ions, Eg plus, gained an electron to form solid silver, which is elemental, so there's no charge on it. So there's another picture which will probably just help you see the visual change that happens over time. So silver nitrate, remember, clear colorless solution, and copper not so shown so well here, which should have been a pink metal here. So over time, when you have this copper being introduced into the silver nitrate, a chemical reaction takes place, and you now know that that chemical reaction goes by the name of redox. The copper was oxidized, lost electrons to form copper ions, which is responsible for this blue color, Cu2 plus ions, and the silver ions, which were colorless, then formed a silver color metal, elemental silver, which is what we see on top here. So there's this visual effect that you can see over time. It's a redox reaction. Again, the same reaction without visuals this time, just trying to explain this using oxidation number at the end, oxidation number at the start, which chemical was oxidized, which one was reduced. So we look at copper. Oxidation number at the start was 0 because copper is in its elemental state and oxidation number of any element is 0. At the end of the chemical reaction, copper formed copper 2 plus ions, so the oxidation number is plus 2 because for a simple ion, its charge is the same as its oxidation number. So it's gone from being 0 to plus 2. How did this happen? It lost 2 electrons. So we show that in the half equation, and the loss of electrons is oxidation, so this chemical has been oxidized. The other chemical we are dealing with is silver ions, because it was silver nitrate, so it is present in the form of silver ions. The oxidation number at the start is plus 1, because remember this is a simple ion, its oxidation number is the same as its charge, so it's plus 1. At the end of the reaction, you have elemental silver forming, so the oxidation number is 0. What has happened to silver in this process? Each silver ion gained 1 electron. We show this in the half equation. And we know now that gain of electrons is reduction. Alright, so what? This sounds a lot like what you did last year. So what's the new concept here? So what we're going to try to do is, what chemists have actually done is looked at this and said, hey look, there's a transfer of electrons. Copper loses and silver gains. What if we separated these two chemicals and we didn't allow the electron transfer to happen inside the same beaker, but we actually separated them out? So let's see how that's done. So before you look at all of this text, let's look at this picture here. This diagram here is made up of 2 beakers. Alright, the beaker on the left has a copper strip that's placed inside a solution of copper sulfate. The beaker on the right has silver that is placed in a solution of silver nitrate. So the reaction that's going to happen here is exactly what happened in the slide previously, which was copper reacting with silver nitrate. The only difference is you notice they're actually separated now. But then you notice these lines on top. What is this line here? This copper wire, this copper rod is actually connected to the silver strip or the silver rod through a metal wire. And in the inside there's something called the silver bridge, which I'll explain in the next video. So let's look at the text now. If the chemicals, which is our copper and silver nitrate, are placed in half cells or placed in two separate beakers in an electrochemical cell, where there is a wire from one half cell to the other for the electricity to flow through. So you have a wire, and why do you need this wire? For electrons to flow through. And you have a salt bridge between the half cells. This flow of electron can be harnessed to produce an electric current. So you know there's a transfer of electrons. Instead of having the transfer happening in the same beaker, you force the electron to travel through a wire, generating electric current, and that's what we harness, and we use them in our batteries, ever-ready battery and Energizer batteries, your cell phone batteries. So what happens in this is a very good example of chemical energy being converted to electrical energy as this electrochemical reaction occurs, or as this redox reaction occurs. A battery, what we call as batteries, can have one or more of these electrochemical cells. So what is an electrochemical cell? An electrochemical cell is known as a galvanic cell, or in some textbooks they may call it as a voltaic cell, or it's called as a battery. It is a simple device to convert chemical energy from a spontaneous, that's a key word here which we're going to use a lot of times, spontaneous redox reaction into electrical energy. So it converts chemical into electrical energy, and the reaction happening there is a spontaneous. Spontaneous means the reaction took place on its own. We did not have to supply energy, we did not have to heat up the test tube, nothing. It's happened on its own. One chemical must be an oxidant and one must be the reductant, but they are not in direct contact. Right? Normal chemical reaction, you have it in a test tube or in a beaker, but in this case they are not in direct contact. They are separated. These two chemicals that are reacting are physically separated in containers that we call as half cells. As the reductant is oxidized, electrons are lost and are transferred through an external metal wire to the other half cell, and the other half cell contains the oxidant, which gains these electrons, and it is reduced. So if you go back to a very basic concept of physics, remember the movement of electrons is an electric current. So we are looking at this chemical reaction, we see the transfer of electrons, and we harness that energy to from electrical energy, and that's what we use. This is the concept used in batteries. So if you see a picture of ever-ready batteries or Energizer or even a standard cell phone battery, this is the concept behind it. So in the next video, we'll look at some more specific terms, like what is an electrode, what is an electrolyte, and so we'll take you through a little more details in the next video.